Now what I'd like to do is show you how to use SPSS to conduct a one-way analysis of variance. For this example, we're going to compare ethnicity groups or ethnic groups on their mean math scores. Now we could use three separate t-tests. In other words, I could compare black to white using a t-test, white to Hispanic using a t-test, or black to Hispanic using a t-test. But every time I make a t-test comparison, my alpha level, or my type 1 error rate, is 0.05. And so if I make three separate comparisons, now my alpha level, or my chance of making a type 1 error, saying there's a difference when there's not, is 0.15. And so we want to keep our type 1 error rate, and we want to hold that at 0.05. And so that's what the ANOVA analysis allows us to do. So I'm going to switch to the SPSS spreadsheet where I have the data entered. And you can see I have a column for ethnic group, and I have that labeled as 1 is white, 2 is Hispanic, and 3 is black. And so now what we're going to do is compare ethnic groups on their math scores using SPSS. So we'll go to Analyze, Compare Means, and One-Way ANOVA. And in this case, as you can see, we want the math in the dependent variable list because it's the measurement variable, and ethnicity, I'll move it back over again, in the factor list because ethnicity has the three levels, white, black, and Hispanic. Now, in order to keep our type 1 error rate at 0.05, if the ANOVA result is significant, we want to do a post hoc test. And so what I've checked is the Tukey. It's one of the most common, it's the most conservative test that we typically use in this kind of an analysis. And then I'll click on Continue. For options, I like to have the descriptive statistics, so I'll check that. That gives us the means and the standard deviations, and the homogeneity of variance test, because that tells us if the variances of the groups are similar or are they significantly different. And then I'm going to click on Continue. Then I'm going to click on OK to run the analysis. So here's what our output looks like. You can see we have our the numbers in each group, so you should check those. These are the means for each group, and these are the standard deviations. This is the result of the homogeneity of variance test. And what this Levine's test tells us is if the difference between the variances or standard deviations are significant. And you can see here that this probability or significance level is above above 0.05, so it's not significant. So we did not violate that assumption. We go here and we see that our ANOVA analysis is significant. And the reason it's significant is because the 0.026 is below 0.05. So it says or tells us that at least one pair of means is significantly different. Now if we go down to the post hoc tests, then we can see all possible comparisons, white to Hispanic, white to black, etc. So if we look at the first set of comparisons, comparing the white students to the Hispanic students, we can see that that average difference is about 3 points, and this negative number means the white students scored lower than the Hispanics, but that difference is not significant. However, when we compare the white students to the black students, it's a little over an average of 5-point difference, the whites being lower than the blacks, and we see a little star here which indicates that comparison is significant, and then we can also see that the significant level is 0.045, which is below our 0.05. Hispanic compared to white, that mean difference is about 3, a little over 3. That's not significant. Hispanic to black, that's about on average 1.8 difference in math score points, and that's not significant. And then we see the comparisons being the same here as we have here, because this takes the white, Hispanic, and black and then makes all possible comparisons.